Good morning, everybody. Today we're going to be working with more trig equations. This time we're going to be working with ones that require more trig identities. So they're going to get a little bit more difficult, some more nuances to these equations, but still the same ideas behind it where we are trying to find all the solutions that work. In this case, we're going to be working with just our solutions between 0 and 2 pi, but we'll see that that is plenty of a challenge for us. So I'm going to start off with finding these exact solutions. The first difficulty that we come across is this 2 theta going on. It is really difficult to come up with two different, or an angle that if I double that angle, we have this going on. So the issue whenever you're doing this is that the fact that we have different angles going on. If we don't have the same angle, super difficult. Luckily for us, we do have our double angle formulas, and we're going to use one of those today. Now, with cosine, you have 3 choices, and the choice is going to make it either pretty simple or pretty difficult. And thinking about which of the 3 you want to choose is going to be affected by the other trig function that you're with. If this was sine, or if this was something that dealt with sine, the choice isn't as obvious, but since it's cosine, we want to use the version of cosine of 2 theta, or the double angle, that only has cosine in it. And if you have that in front of you, or if you remember, it is 2 cosine squared theta minus 1 is equal to cosine of 2 theta. So once we get that switch, we're back to our normal, air quote, normal equations that we have been working with. It's quadratic, so we're going to move everything to one side. And factor it. Again, you could use the little trick where you can substitute cosine for x and then substitute it back in at the end. I'm going to leave it like this just so we can get that practice. But it looks like 2 cosine, cosine. Both are being minus, or it's minus and plus, so both need to be minus. 2 times 2 is 4, plus 1 will give us to that 5. So this is looking pretty good. Next, we are going to set up both of our equations. So cosine theta is equal to 1/2 for this one, and then cosine theta equals 2. That should be a red flag, or that should be a red flag. Cosine can't reach 2, so this portion has no solution, which is nice. We don't have to list as many things. Cosine theta still has some solutions for this, though. So theta is going to be equal to pi over 3 and negative pi over 3, but remember 0 to 2 pi, so it's 5 pi over 3 if we're going counterclockwise. So those should be your 2 solutions. You can go back and check, plug them in. Do they actually work? If they don't, then you know that something went wrong and fix it. Same process here. Sine of 2 theta equals cosine theta. Nice, the gift and the curse here is the fact that sine of 2 theta only has one equation, so we just have to use that one to get to the same angle. Again, we have to have the same angle before we start doing anything else. So this at least gets us to the same angle. And this is the double angle formula of sine, if you don't recognize that. The issue here, though, is now that we didn't get rid of sine, we didn't get rid of cosine, so we have to kind of just work with this. You could treat this like a quadratic equation, get everything to one side. And then you can factor out cosine. And if you hear my kid screaming in the background, he is awake. This is filmed a little bit later than usual. So from here we have cosine theta equals 0, and then sine theta equals 1/2. Be careful, if you just divided by cosine to get rid of it, you would be eliminating a couple answers, so just make sure you go back and see, well, which solutions did I divide out. Same thing if you were to divide both sides by x, sometimes that eliminates some answers, so just go back and check, did you get rid of anything? In this case, you would have gotten rid of 2 solutions, so this is pi over 2 and 3 pi over 2. Theta over here is going to be pi over 6 and 5 pi over 6. All together, again, those should work. You check on your calculator either through graphing or plugging them in to make sure that they're the same value. Moving on. Tan of theta, cotan of theta. So you could probably reason through this one, but you can also use this idea. And I like this one just because it is methodical versus just thinking it through. It's nice to have some algebra steps behind it just to help you reason. But you could potentially figure this out without any of this algebra. This one is simple enough, but cotangent is 1 over tangent. So I switched it just so that the same function, same angles being plugged in, so nothing going on there. But to get everything to one side, you can say that tan squared of theta equals 1 by multiplying both sides by tan. Now if you take the square root, you have to do plus or minus 1. So the tangent is 1 at pi over 4 and 5 pi over 4. It is negative 1 at 3 pi over 4 and 7 pi over 4. You could put these in order, but again, if it doesn't ask you for the order, I don't care. Alright, cosecant squared equals cotangent plus 1. The issue is we don't have the same function going on. Both are over sine, so you could multiply both sides by sine squared, I guess. I wouldn't do that. But we do have our fancy schmancy Pythagorean identity that we can work with. One of the versions, if you look at that 6.3 sheet, or it should be in your purple sheet because it's a pretty big one, cosecant squared is equal to cotangent squared theta plus 1. So now we're back to semi-normal. Quadratic, so subtract everything to one side. Ones cancel, left with this. I would factor out a cotangent. So cotan theta equals 0. It also equals 1. Cotangent is, remember, the reciprocal of tangent. So this is where tangent is undefined, or where cosine is 0, because this is cosine over sine. So when cosine is 0, we have pi over 2, and 3 pi over 2. And then cotangent is 1, where tangent is 1. That's pi over 4 and 5 pi over 4. If I was to put them in order, this would be first, second, third, fourth. So just keeping that in mind if it is something required of you. Okay. If you're looking at the note sheet, you'll notice that I skipped 5 and 6, basically just plugging it into your calculator and finding the zeros or finding the points of intersection. just be mindful of the range that it's asking for. It says negative pi to pi, not 0 to 2 pi. So just if something comes up like that, make sure you're using the correct x values, or theta values, I guess. But yeah, should be it for today. Just more practice on trig equations. It's a pretty big section. They get difficult and have lots of wrinkles to them, so want to make sure that we spent a lot of time on it. But I believe next one switches it up a little bit, so we should be moving away from that. But until next time.